Can you hold that for a second? Thank you. All right, hey, I need to get this up. All right, guys, that is a true indication of how well, can you pull that top up? How I am, there we go. All right, where am I? I am at Printer Filament, and they are foolishly gonna let me make filament. So, they foolishly let me sit at the door. All right, so Mitch, help me out here. I'm looking there, and that looks straight?
Yep.
Good, thank you. All right.
Do you want to change the spool, or do you want me to change this first one?
You change the first one. All right, can I show what it looks like?
Yeah.
All right, this is Mitch of Printer Filament, and we are back here at the back, and what you getting ready to do?
We're gonna change spools. So, actually we're running pretty slow today, so every 6 minutes here, we're gonna swap out a spool. We're making a fun new material. This is PHA today. So I'm gonna make Courtney do this right here. So this spool just stopped, and I'm gonna set this down. I'm gonna talk like this.
Now,
what I'm gonna do is just kind of, the winding process is find the little dots that I'm gonna terminate in. We cut the spool here. The line is paused. I've got, I don't know, a minute or two to do this. At this part, this is personal preference. I like to dewind and rewind a little bit to make sure that this filament is snug up against this wall here. And we just terminate it. That's pretty easy. Probably do all this all day long. Take this off. Now we've got a spool. Just set that behind me. Grab a fresh spool here, pop it on. Put our lock back on. We're gonna rehome this so the guide that goes back and forth is gonna line up nicely. We're gonna start this spool, give it the first wind manually, and then hit OK. And now it's gonna run. And now it's running. You're a little bit. There we go.
It's hard. All right, here, you take over for a sec.
All right. So yeah, that's it. I don't know if you can see that. We're winding. This is PHA. PHA is a biodegradable plastic. So you can throw this in the ocean and it will turn into fish food, basically.
You said anywhere that there is stuff that will biodegrade. So if you were to put this in your garden, in your backyard,
yep.
Right? So the important thing about this is we have been told for years that PLA truly biodegrades. And we found out later that it can biodegrade, but it has to be like in industrial composting situations, which we're not going to have as individuals. And it's really hard to find a location to do that. So this, you said, could be the PLA killer, right?
Yeah, so all right, a lot of people come to us with all sorts of weird, wacky ideas. They tell us that it's going to be the best thing ever, it's going to change the industry. I'm pretty used to hearing that. Most things never even make it out the door because there's a lot of challenges. I mean, one, it has to be affordable is a big thing that you can tell pretty early on. The next thing is I need to be able to make it in a filament. That's usually a showstopper for most things. They just don't wind up right, or they snap, or they're not consistent enough. And then after that, everything that makes it through that gauntlet still has to be printable at all. And a lot of things will be challenging to print. So like, call those mild successes. Very rarely does something go out the door that's like actually easy to print. And this is it. It kind of hits all those criteria. I think right now it's still on the pricier end a little bit because this is a new material, but it has room to go down. We're doing like, I think 750 grams is $30. I don't know, it's on our website.
So it's not the most inexpensive, but as you all know, when you first start something, we have to have economies of scale. And if you think about this, PLA, which is made not necessarily from corn, because we've heard that, but PLA is made from sugars, and it's actually fermented, right? It's fermented, right?
Yeah, PHA is made like beer in batches.
Yeah,
so
in batches. So the more demand that we have, the more batches of PHA filament beer we can make. So right now, I'm interested in trying out. Now, I had asked you, Mitch, what about colors? You know, I like colors. So what's the status of colors?
So colors are tricky. Right now it's just black and natural. There was a few other colors that were supposed to be coming here, but it sounds like they didn't pass the biodegradability certification. So it's really hard to make stuff biodegradable. I don't actually do this. I just melt the plastic. So there's a guy named Fred over at Ecogenesis Biopolymers. He's kind of the brains behind this whole thing. I'm just regurgitating the stuff that he's told me. But anyway.
But wait, okay, so, but glitter. I love glitter.
Yeah.
I love colors. If the colors, the pigments, and the glitter aren't biodegradable, then we are eliminating some of it's biodegradable.
I'll go grab
We're still
some
leaving
colorant.
problems.
Give me just
Okay,
a sec.
go
I'll
get
be
me
right
some
back.
colorant. So I'm going to look at this. I'm going to look at this spool again, guys, because I am going to get a ding, and then I'm going to get, that gives me a little bit of time, and then I'm going to get a second ding, and then I'm going to get a third ding. And see all these little spools here? This is what they told me I had to get done today. Actually, they just trained me on this a little bit ago. Oh wait, here you go. Oh, you've got colorant.
All right, this is just a small amount of colorant. So this is what those pellets look like. Colorant is a pigment, which is usually like a powder or sometimes even a liquid, but it's used with a binder agent. So basically something that makes it into a plastic again. So it's usually some other form of plastic. So typically with most filaments, the plastic that holds that together just needs to be compatible with whatever your end filament is. So if you're doing PLA, it just needs to be a material that's compatible with PLA, which actually sometimes, believe it or not, is PHA. But anyway, that's called the carrier resin. But when you're making PHA, the goal is for it to be biodegradable, which means that every part of this, the pigment that gives it the color, as well as the carrier, has to be biodegradable itself.
Typically, that is extremely concentrated, and so you have like a lot of the pellets. And we're not at the other end of the line here, but the way that, and you can't see it because it's in a bin, but the starting material is actually a bunch of pellets that look like that. But they're, in this case, they are this color. They're the natural color of the PHA, and then you can add just, oh, there's my first ding. Now, when I do this, hi there, hi guys.
By the way, Fred from Ecogenesis is in the chat, so
hi Fred.
If you guys have any really technical questions about like the science behind PHA, he's your guy. He knows way more about this than I do. I know the filament stuff. I don't know the material stuff.
Right. So this is, first of all, we're excited about it being a filament, but it also, hi Fred. It also is. Oh wait, hold on. I got to do my job. All right. Make sure I did this right.
Here, let's see if I can get this
in
here.
All right. So the first thing is, I'm going to hold on to this. You never
rotate it a little bit more so you get to an ending point of the spool. Keep going more.
Keep going. You want more?
So you get to the double.
Here,
there you go.
to the double. Okay. Never let the end of the filament go, right?
Yep. Always hold it.
Always hold it. I'm going to unwind it a little bit so that we can get it nice and at the edge here.
Yep.
Never let it go. Why? Because don't want to introduce any knots in the filament. All right. So I've got it. Now I'm going to turn this counterclockwise. Pull this off. I'm going to go over here and grab a spool. What about that steel spool?
This was our April Fool's joke. It is a steel spool, and we actually just got the shipment of all of them in. So if anyone wants a very heavy spool, those are real.
Now I'm going to pull this out, and I'm going to
hit your green home button.
Oh, you want me to hit home?
Yep. So if you hit that adjusts this guide to make sure that you're starting at the right spot of the spool.
So this is the neat winding.
Let me see if I can get in here.
Oh,
tripod.
You want to see? Okay. Oh, here, I'll make the tripod shorter.
No, you're fine, you're fine.
Here, move it down. Is that okay? Okay. I'm going to spin this around. And once I've gone once, now I'm going to tell it to start. And there it goes.
And that's it. Now we watch it as it winds.
This is about 6 minutes per spool. And you are running this very slow because I am here.
No, I mean each material runs at a different speed.
Yeah.
This one we found works better when it's slow. We're going slower than the last time that we made it just because I don't want to run experiments while we're on a live stream, while I have a guest over, so too many variables.
Too many variables. So when the way, here, you're higher and I'm lower.
I'm checking on the chat to make sure.
Oh yeah, make sure.
By the way, I'm watching chat over on my phone here, so if anyone has any questions, throw them in chat. I'm reading.
When filament is extruded, it comes out, and as you all know, it's really important to get that diameter. We all want that diameter, a really tight diameter, and it comes out, and then there is a process of making sure that from the point where it comes out and it's still molten to the point where it's dried, when I just put it on this spool, we want to make sure that it's at the right diameter. And so there's like a pulling and a relaxing. It's all about, if you were going to take a bubble gum and stretch it out and you want it to be the right diameter, you see what, that was bubble gum is not a good example. But in any case, there is a lot that happens to get the tolerance to that 1.75 millimeters with just a little bit. And you all have really good, I know that's one of your big things, Mitch. Mitch is big on quality.
Yeah, we're picky about stuff, we log everything. I can show you some of this
okay.
stuff up here. This is our run over here. Oh, there we go. This is where we're tracking everything. This is our diameter. We're tracking our ovality, the previous stuff. It's a lot of just info about the spool and all of it. Oh yeah, I mean,
see that ovality?
There's the ovality thing. That circle is like multiplied by 100x to show you how it's like, right now it's narrower than it is tall by 100x. And we print that on the spool. So each spool has a label that tells you all of those stats. So let me grab the one that we just had here. This came off the printer.
And by the way, they put my name on it.
Oh yeah. Oh, it says Z on this one.
Oh, it says Z.
We're gonna change it. So the ones that she's about to make will say made by Courtney on it. But this spool right here, it prints it right there, is the ovality. This one's 0.9% ovality. This spool came out to be 0.013 millimeters tolerance, I don't know, diameter deviation rather. So a 0.01 spool is generally how that is. We just add an extra digit so we can keep track of other stuff. But the stuff is coming out really nice. Most filament companies tried to hold, I don't know, 0.05.
Yeah.
0.02 is like the gold standard, and we're at 0.013 right now, so we're doing great.
And that ovality thing, I just want to say, on that picture is extremely exaggerated. It is not going like this. But ovality is something that is not talked about very much. In fact, the first time I really became aware of ovality, I say that wrong, was when the co-extrusion filaments came out. And it was important that if I had a red and a blue, and I was printing something that the red stayed on the red side and the blue stayed on the blue side, and it didn't like wobble, ovality was really important. They were intentionally having a little bit of ovality, so as it would go into your extruder, it naturally liked to stay in a certain orientation. But we hear tolerance, and there's tolerance between, how that it's 1.75 millimeters in diameter as a whole, but we also, the ovality is something that not a lot of companies track. Do you know? Do a lot of companies track? Oh wait, here comes
yeah.
the big
So
question.
a pretty common thing. So there's different variants of complexity. This right here is our scanner, and you can see that there's two numbers there. On the top one, we're at 1.74, 1.75. Bottom one is also 1.74, 1.73. That's scanning it like an X shape. So it's kind of like an X-shaped laser beam. We're measuring the width and the height of the filament. Which makes it, I'm going to steal your chair.
Here, use it.
It makes it really weird when you're trying to describe what is the tolerance of a spool. So if it's a little bit thicker than it, like wider than it is tall, which number do you use in your tolerance? Because most filament companies will say that they're using the average tolerance, which is halfway between the two. There's a bunch of other weird ways to fudge diameter tolerances and stuff. Some people will average the entire spool and say, hey, on average, this was 1.76 millimeters, so that's 0.01. But we track all the little blips and stuff. All right, Courtney, this is all you.
T-N-E-Y. Okay.
Got another spool change coming up here.
All right, I'm getting ready. Hopefully I will do this and make you all proud.
There was somebody was asking about humidity, and actually this is something Fred already jumped in a little bit on. This stuff is really moisture resistant. So like typically when we get pellets in, you got to do a lot of drying. This stuff is not really picky about drying, and on top of that, we could seal this, or we could skip the sealing for the most part and skip the desiccant packets that go in here. But the only reason that we're sealing them and putting desiccant is just because it's easier to do that than it is to explain to everybody that it's not necessary. But it is not necessary. You don't need to like store this or dry this before printing. This is kind of a new material. We've had it for, I don't know, I've got some old spools that are maybe 6 months to a year old. Not quite a year actually. Fred's got some older ones, but we do print with them occasionally just to see if moisture impacts anything, and it doesn't seem to care about it. I already changed the name on that.
Oh, you homed it? Wait, there we go. So a question that I of course had was, it's still making filament. The extruder at the other end is still kicking out filament. It's not stopping, but there is a little thing called an accumulator that is giving us a grace period.
Do you want me to get that on video while you're doing this?
You want to do? Oh, whoa! I just did it. Yeah, go for it.
So this is the accumulator. It's this bar up top. You can kind of see filament is wound back and forth on it, and it comes all the way out to the second spool, which is now starting to move in. So that is what buys us time.
Okay, cool. We're supposed to be
So
up
that
there
stretches out over the
in,
length of the whole
in a few
line
minutes. Okay.
when we need to switch out a spool. And then as soon as the spool is restarted, which it's doing now over here, I'll back this up a little bit. Now that it's running again, now the accumulator shrinks and goes back to its resting place, I guess.
Mitch, I know you're not. Thank you for talking with me about this, but I know something that I found really impressive. I'm going to do this so we can kind of both get it. Something that I thought was really impressive with Mitch was a lot of companies are coming out with their like PLA Plus or Pro or something, and so I said to Mitch, you know, I asked him about this, and he said, well, honestly, I got to tell you something. We don't have any of those because we only make our best filament. It's like putting your best foot forward. Mitch is really, and it's one of the reasons I really enjoy hearing about what he does. He's super interested in quality, and he knows so much, and I've learned so much from talking to him, even today. But yeah, so yeah, why don't you have a PLA Plus, PLA Pro, PLA Mega?
I could like not hear you when you were in front of me. I was like, I hope she's saying good things.
No, I was saying that you don't have, you can say it better. Why do you not have a PLA Mega?
So we make for a bunch of different brands. Right now it's like 9 main brands, but we have a few more that we do occasionally. And because of that, I get to see the secrets that not everyone else gets to see. So like, what is the difference between PLA and PLA Plus? And I can tell you, at least across the 9 brands that we're working with and some of the other ones that we've reverse engineered, there is very little rhyme or reason to it. Most of the time, the only thing that you can really guarantee is that a PLA Plus is better than the PLA regular of that brand. So don't ever compare a PLA of one brand to a PLA Plus of a different brand, because it doesn't mean much.
That makes huge sense. Yeah, that makes a lot of sense. And yeah, because there are a lot of things. Now, you said something that I think is really interesting. There are a whole lot of companies. If you go to Amazon, is a good example, and you see all of these brands making filament, and even some in the U.S. So the question is, do they all have their own extrusion lines? Have they learned all of the things that these guys at Polar Filament have learned in order to make this? And a lot of times, companies don't necessarily do that themselves. They're interested in the colors they want or the product they want to put out, but they're going to hire somebody else who's an expert at making filament, and there's nothing wrong with that. I have always said to everyone, white labeling is not a bad thing. You're potentially asking a company who is better at this than you might be to help make the filament. So I think it speaks volumes that you all have not just one, but you make filament from multiple companies, and you seem to want to know everything about, like, I wish I could hang out here. I live in North Carolina. It was snowing earlier today. It was over 80 degrees in Raleigh, North Carolina yesterday, so I'm really excited to be up here. I have my jacket out again. But yeah, I'm just so excited being in here and seeing all the stuff you're doing. And I've bothered Mitch all day. He hasn't been able to get much work done with my questions. All right, there was a big question there.
Yeah, there's a few things going
Okay,
through.
oops, I didn't stop talking. Okay, go.
I forgot what I was going to say. I was going to talk about the white labeling. So, I mean, we're good at making filament here. That's like, if you ask what we're good at, I do a lot of work on machinery. I like to do a lot of machinery rebuilds. Pretty much the whole line at this point has been torn down and rebuilt from scratch, just on traditional machining equipment. So lathes, Bridgeport, CNCs, and stuff like that. It really helps custom make everything. But anyway, that is a very different skill set than marketing and branding. And like, I mean, if you go to our website, we just kind of like take a picture with our phone, make sure it looks good, and that's it. I mean, I'm not as picky about other brands, where I know other brands are all about making it look phenomenal. And I mean, same product. It's just a matter of whether or not you're going to make it look gorgeous, and do a lot of branding on custom boxes and going to events and making advertisements and commercials. So it's pretty normal to find that like white labeling technique, where you'll have a brand will source all of their stuff to 4 or 5 or 6 producers, and then each producer or manufacturer will make for a bunch of different brands. So I don't know if anyone's ever had a spool where you get like all from the same brand, and you find that like the blue and the yellow and the red print great, but for some reason black is just horrible. Like, you just find that one color that prints different. There's a good chance it came from a different building, a different manufacturer, and they've got their own internal standards. So that's kind of the underworking. That's pretty normal just outside of filament too, in the manufacturing world. You don't want to put all your eggs in one basket with manufacturing, so you'll find that quite often to kind of like smooth out demand. All right, I want to read through some of the comments here. So the raw material, so how does price compare to PLA? So yeah, Fred was talking about this. The raw material is more expensive. we're doing a lot of the stuff that we can do to optimize the overall cost. So I think right now on our website it's $30 for a 750 gram spool. So it's more expensive than PLA, but there's some really expensive stuff that we've made in the past. Like I think nylon 12 is like $40 for half a kilogram. We've got like ESD PLA is like $50 or $60 a kilogram or something like that. So it's way cheaper than some of those weird specialty materials. And then, I mean, Fred's going to probably know better than I am about like what the economies of scale look like for the raw materials. So I don't know. I'm at the spot where I personally use this stuff all the time, which is my own internal metric of whether or not something is usable or not. There's a few more things. Oh yeah, Fred's saying Filaments Canada. I think that's Canadian Filament. He's over on the western side of Canada. I think he's in like Edmonton. I was just in that area, somewhere in that area.
Alex?
Yeah.
The other Alex? Yes,
somewhere
yes,
in
he
Alberta.
is. Yeah,
I think
he
it's
is.
Edmonton.
Yeah.
I was just over there, and I forgot that he was
he's a
over
great guy. Yeah, he's been doing some interesting things.
What's the temperature resistance? So PHA has a higher temperature resistance than, I think it's pretty comparable to ABS actually. I think it was over 100 or 100 C. So PLA is safe up to about, we'll call it 60 C. PETG is about 65 or 7, not quite 70 C. And then I think ABS is about like 104 C.
Yeah.
So this stuff is about the same as an ABS, right around the 100 C mark. So like we've been joking around that you could build an entire Prusa printer out of PHA. Even the stuff that needs to be printed typically out of ASA, a higher temp material, because even that, when you're around that hot end, this should still survive that, which is pretty cool. So talk about it a lot, but still yet to be done. Temperature resistance, deflection temperatures. Does it print open air or need an enclosed printer? Oh, actually, that is one of the weird things about this. PHA does not like heat. One of the things that's very unique about it, and I believe this is the reason it's biodegradable, is or one of the reasons, is that the crystallization temperature is basically room temperature, a little bit colder than that. So it will actually crystallize without adding heat. Whereas with PLA, you typically put it in an oven at like 60 C or something to get it to anneal. This stuff kind of happens in the open air. So because of that, though, you want to typically print cold. Cold meaning no heated bed. Like just room temperature bed. I actually printed this out in the snow just to see how that did, and it printed pretty well.
You put it in the yard? It was snowing?
I put it in my patio area, so I meant to get a video of it. I did not, but it succeeded. I found that the best materials to print with, if you don't want to buy another print bed, just print with like blue painter's tape. I have not had a lot of luck with the
Super Tack?
PEI.
So
yeah. PEI is built for basically PLA. It's really optimized for PLA. Not so great for PHA. But the blue painter's tape works great. But the bed that works the best is, that I found at least, is the Biku Cryo Grip
Is that
Glacier.
bright blue?
It's a blue one,
really
and we can go
bright
show
blue.
it. So those ones are designed to print with no bed heat.
Yeah.
And not only do you not have to worry about it peeling off, but typically you have to worry about the opposite thing, which is it sticks a little too well to it. So that's pretty much it.
Something I was going to say is, if you are interested in, because you've got your hands, you're doing all kinds of interesting things. Like you just did, Bio TPU is another one.
Yep.
And you've done some, like you've taken nylon powder, that's waste nylon powder, and turned it into nylon filament. So that's one of the things I love. But go to and join the Polar Filament Discord. Like just the other day, you said, oh, I've got some filament I just need to clear out. Here, rock bottom, boom. So yeah, and people, so if you're interested in grabbing some deals or finding out about the latest new stuff, go to your, I always miss it though.
What's that?
Whenever you do the
yeah.
deals, I'm doing something, I come back hours later and you're like, no, that's gone, man.
Discord is where I just kind of put my open thoughts. So like if we're having successes, I put those on there. When we have failures, I put those on there. It's kind of the behind the scenes of what's going on. It's way less filtered, like low production. I mean, it's just me over here one day and I'm like taking a picture of a spool that explodes and I'm like, oh, wow, that stinks. And, I mean, it's just a lot of stuff like that. So if you want to see a day in the life of how filament's made, that'd be the place to do it. But also like all the weird experimental stuff, that's where we post it first. A lot of really smart people that are in that Discord. So like whenever there's debugging issues or something, or if we're making a new weird material, like, I mean, PHA was one of those materials that early on, it was new. It was the first time doing it, and we needed to get that in the hands of some early adopters. So Discord is where we went to kind of send those messages out, figure out people that actually knew what they were doing, and hear their opinions on it first before we release it to the true public.
I would love to get this volume to scale, right? That this is able to get in a much bigger volume because it'll drive the price down. And then there is work to be done for getting colors in and glitters and all of that. So there's more work to be done, but I would love to see it drop down. And I always look at something. There are multiple companies that are making filament, and they're making filament in the U.S. I'm thinking of some, and their prices are higher. They're higher than other companies, but they're paying their employees living wages. Wait, is that my turn? Am I up? Do I have one for Bing?
I am not paying Courtney though.
He's not paying me. No, I asked.
This is how we keep our
raise.
prices low. Is we recruit YouTubers and they do work for free.
All right, here, come catch me doing this. We need to head up front because we have said,
Oh yeah, we promised.
We had said,
Oh yeah, that's the other thing is if you're in the area for the next 2 hours, Courtney's going to be running the storefront instead of the. She's doing everything today.
I'm doing it all.
So we're just going to be out in the storefront, chit-chatting, selling filament. And these spools actually say made by Courtney on them, so we're going to bring those ones out
I'm
front.
so excited.
So somebody wants a made by filament stories, you can get one of those.
Turns out you couldn't put filament stories because it didn't like a space.
Oh yeah.
But you could do Courtney.
We did Courtney. Yeah, it does not. Our program takes first names only.
But yeah, no, this has been fun. It's been a lot of fun seeing filament being made. And actually doing this, I have never done this. I hope you can hear there's a vacuum cleaner going on.
That's the vacuum loader, so we're just loading more up into the hopper.
Oh, into the
Don't forget to home it.
Thank you. Home, James. Go. Okay.
Go.
All right.
All right, we can turn this over to Z. And right before we walk out, we can at least walk.
Oh wait,
look
no,
at what
we
the
have
raw
to show you
material looks
my
like.
favorite machine. Hold on.
Oh,
I have a
vacuum
favorite
sealer.
machine. Okay, come this way.
It's just a normal
Maybe you can come
vacuum
this way.
sealer.
All right, so these are the stickers that come out. I'm just so excited about this. I might have to buy one myself. See, at PHA, and it tells about it, the date. It also shows the information on the extrusion, and you can go to that QR code, and it will show you all the information.
Yep, everything that we collect, all the diameter data.
That's my Courtney. Okay, so I'll do one of these, and we'll go up front. The bag, you are putting it in the bag, but my favorite machine, I have seen these. I'm building this up. You guys are going to be like, oh, that's not exciting. I messed up earlier. I didn't put the desiccant pouch in, and Mitch is absolutely right. I have heard it so many times that people will say, I'll say, but it's not a hygroscopic filament. It doesn't need to be. But there is a lot of, these bags, I can't open it. They do not want me to open them. Okay. I got it. All right, so got it here. One more desiccant pouch. These desiccant pouches are out right now. They only take a few out at a time because guess what? If they're out, we're long. Okay, this is my favorite machine.
Oh, here we go.
Over here. Okay, this is the vacuum sealer. Now, I'm going to put it in here, hold this down. And the thing is, when I close this lid, it's going to start doing a vacuum, but it did it in a way I didn't expect. Here, can I roll this up to get that? Okay. All right, so I'm going to close it down, and you'll hear it start. All right, hear that? Let's see if we can get. Watch it at the end. That's my favorite part. Did you see that? Like right at the end. It's like, and then it lets go and it goes. I love that. Okay, shall we go to the front? You want to go to the front? Okay. Hold on. That one still needs to go. I need to take.
Look at the raw material too on our way out.
Oh, okay. Let's do it.
All right, I got to mark these as good. We had 2 good spools, so that clears those out. Everything is still, it's all automated. We get good grades on it, but it still kind of comes down to the person running it. You're the final say of whether or not they were good spools or not.
Yeah.
All right.
And I'm just going to keep talking. Well, oh, you showing stuff?
Yep, I'm going to get There's some stuff I can show and some stuff I can't. I will show this stuff. So this is the dye as it's coming out over here. So that's the raw material coming out. And then this is the raw pellets. So here we go.
Right in there.
That little window is a preview. It looks like fish food. Kind of got like a grayish tan color to it. Each one looks different. You want to open this this big
Open
box
it?
here?
I
the
can?
Gaylord? Yep.
Oh.
So
Oh my gosh.
That right there is the raw pellets. I don't know if PHA matters if you touch it or not. I usually avoid touching it to avoid getting oils on it. We vacuum load it.
This is, hold on, this is an interesting size. So you can buy, you know, a kilo of something or whatever. This is actually a measurement called a Gaylord. Gaylord. And it is how much is it in weight?
It's usually right around a ton.
A
so
ton?
it can be like 1,500 to 1,800 pounds depending on the material because plastics are different densities.
Okay, because I was going to say, this is a size, not necessarily a weight.
It's 4 foot by 4 foot. Typically by 4 foot, so it's like a 4 foot by 4 foot by 4 foot cube.
Okay.
There's variants, so like some of them are not. Like we got the ones that we use most often are like over in this area, so there's just different materials. Yeah. This is just kind of the stash of ones that we use frequently.
So this right here, Inigo, this is NatureWorks.
Yep.
This is the vast majority of the filament you probably ever printed with was made with this.
Not necessarily.
Oh,
no,
PLA.
There's PLA, but there's Ingeo, Corbion, and then like High Sun. So there's
well, the Corbion.
different
You know what? Okay, if you're printing with Chinese filament, if you're doing rainbow filament, you're probably doing. Yeah, that's true. That's true.
All right,
we're coming back.
The live stream.
You all might be able to hear us better now. Ah, I didn't realize how loud it was.
There might be people up front too, so we might.
Okay.
Oh, I left my phone. No, I got it.
Okay.
Okay, do you want to end the live stream or
Let's
what?
end the live stream. All right, all right. Here, let me show the front.
Okay.
And then we'll end. Okay, guys, if you can make it, if you can make it to Polar Filament, I'd love to see you. This is the front where they have all their stuff out. And they have a very small Flexi Rex. It's crazy. So I'm going to be at Rapid TCT in Detroit for the next 2 days. So if you're in the Detroit area, come down to Rapid TCT if you can. And I will. Oh, and don't pay. Sign up as like bring a friend, and you should be able to get in for free. All right. See you guys later. Bye.